very easy. They're just rules. All right. So for section 9.3, all right. Now they're going to talk specifically about the arcs and chords. All right. Yesterday we talked about the measure and we talked about the length. Remember, measurement is like you measure an angle. All right. That's how I learned it. All right. Which means you're going to measure it in degrees. Length requires a distance. All right. So those are the things. All right. Now, today there's certain properties, all right, about arcs and chords. All right, and it's just obvious and it's simple. All right, so let's look through it real quick. All right, up here it says arcs and chords. Points on a circle determine both chords and arcs. Several properties are related to points on a circle. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now, what does that mean? So let's blow this up real quick. All right. If I tell you that, RS is congruent to TV, then what does that mean? Someone who's paying attention. What does that mean? If RS, if chord RS is congruent to chord TV, what is true?
The arc of RS.
Yeah, it's really obvious. All right, so that means that RS, arc RS is congruent to arc TV. That's how simple it is. All right, and obviously the converse of that would be true as well, which means if arc TV is congruent to arc RS, then the chords are congruent. All right. Now, generally, it is in a single circle, but you can do it if I said, for example, let's just take this. Let's say those two circles are equal, and I say CD is equal to RS. Then arc CD would also be congruent to arc RS. All right, does everybody see that? It's just obvious, right? The circles are equal. All right, if the chords are equal, then their arcs are equal. That's all there is to it. All right. Now, that's all there is to it to this half. All right, there's one other thing, well, two other things that we need to talk about. So over here, all right, now again, if you want, let's just do this together. Just take out your calculator or whatever. You don't have to write anything down, all right? You just pay attention. This will get you through the work, all right? And then I'll just assign the problems out of the book, all right? This is like the example. All right, so if you're looking here, we're trying to figure out what RS is. We're trying to figure out what RS is, all right? So how do I go about finding what arc RS is? Someone. Come on. Tell me. How do I figure it out? You don't even have to tell me what it is.
You do 360 minus 64.
360 minus 64.
And then you do that answer divided by 2.
And then you do that answer divided by 2. All right? Does everybody agree with that? Anybody have any issues? Come on now. Make sure you're listening. All right, so what was that answer? 148. So, well, you divide by 2 because this arc, good question, this is equal to this, right? So that means that arc is also x. So then you could say 2x plus 64 is equal to 360. But I'm expecting you guys to just say, well, 360 minus 64 is what? 296, right? And then 296 divided by 2, because those are equal. What'd you say? It was 148? Right, 148. Come on now. You have to agree with me right now. That's simple. Simple. All right? So if I ask about number 2 now. All right? Now, what is the measure of arc DE? Right, so this right here would be what? 116 degrees, correct? Now, who can tell me what the measure of angle X is then? Yeah, this is what I thought was kind of weird. kids didn't know this. Yeah, obviously 116. Please look up and see if you understand what I'm saying. Right? This arc, watch. This arc is created by doing that. Does everybody see that? All right. That arc is how many degrees? 116 degrees. Which is exactly the same as the what? The angle. Doesn't that make sense? Right? So that's 116 degrees. Again, I was confused why people didn't know that. Right? And let me just put that in context here, right? Here's another angle. Please watch. Here is the angle here. Does it matter how big that angle is? If I go here to here and here to here, did the angle change at all? No, that angle did not change. Just because the angle is larger, all right, doesn't create or does not change that angle measure. Does everybody agree with this? All right, so hopefully you understand that. All right, so now they're not saying it's congruent. They're telling you that the measure of LM is what? 4. So arc LM has to be what? 82. Now again, honestly, guys, fill it in, but make sure you're listening now. All right, I'm telling you, it's. I think it's just super easy. All right, here we go. So let's look at 4. All right, same kind of principle here. I need help with AC. What is arc AC? I got 135 degrees also. Right, again, for those guys who just walked in, this, because the chords are equal, the arcs must be congruent. All right. So let's look at number 5. So what's true here? Yeah, but just tell me the answer. X equals, right? X equals 7. Any issues with that? Anybody? All right, let's look at 6. So, can we solve that one too? X equals 2. Come on, practice your mental math. Everybody should be able to look at that and say X equals 2. All right, because 5x minus 5 is equal to 2x plus 1. Everybody good? Now, that's what I'm talking about. You guys sitting down. You guys are trying. Some of you told me you're trying to do better. You're not asking me questions, so I'm assuming everything's good. Anybody have any questions? All right, let's continue on. 7. All right, same principle, guys. What's this? Yeah, x equals 2 again. Mental math. I'm trying to make sure they're not asking for a specific. It just says find x. All right, so over here, x equals 6. X equals 6. Right? Any issues? All right, over here. Uh-oh, they're trying to be tricky. What's x equal, guys? Well, I got 13, right? I got 13. Is everybody okay? Because YZ is how big? What's arc YZ? Yeah, 162, right? Everybody okay with that? Yeah, I told you, simple, right? Everybody agree? Simple, simple. All right, let's go down here. All right, now the other two parts. All right. So now it says, in a circle, if a diameter or a radius is perpendicular to the chord, then it bisects the chord and its arc. All right, so I'll give you an example up here. OW is perpendicular to AB. So just somebody tell me what's true. What's true? Go. OW, yes. So what else is true now about that? Now that it bisected, what's true? Specifically, tell them. AX, ooh, AX is equal to what? Come on. AX. Yeah, these two things are equal, right? That's what it's meant. You with me on this? All right, because I don't know anything about how far it is down there. What else is true? Come on. Say it.
Like the measurement of the arc is cut in half? So it's
Yeah, so what's true? Not necessarily 90. Yeah, arc AW is equal to arc what? WB. Come on, I think that's pretty easy now too. It says bisect. Bisect means cut in half. Everybody good with that? Any questions with that? All right. Yeah, here's the other thing. All right. If RS is equal to AB, all right, that means they have to be the same distance from the center of the circle. All right, that means that OX would have to be the same as OY. All right, which is kind of interesting. All right, but it's true. So I'm going to try to draw another chord. This chord is the same as RS. So if I draw the perpendicular from here to here, what's that going to be the same as? It's going to be the same as what? OY and OX. Right? Come on now, I think that's kind of easy. Right? In other words, it doesn't matter where I put this. It doesn't matter where I put that chord. It's always going to be equidistant from the what? From the center. Now, equidistance, now, I'm not sure how long or if I even said this, so let's try to make sure you're hearing me. The distance is always the shortest distance, which makes it perpendicular. All right? Does that make sense? All right, I'm not going to say, for example, this is the distance, because that's not what? Perpendicular, right? But if I make it this way, now it is perpendicular. All right, so that'd be the shortest distance. All right, hopefully I'm making sense there. Blush. All right, so here we go. Let's look at this. Last little bit here. So in circle P, if the radius is 13, all right, now I always tell kids, even on the SAT and the ACT stuff, draw in a radius. That will be super helpful. So let me show you what I mean. So draw PR. What is PR? The radius, correct? So that means that's how much? 13. Now if you want, you can also draw it over here, and that is also what? 13. All right, so now if RS is 24, what is RT? 12, right? So we're just drawing that in, 12, 12, which means PT is how much? Obviously. What is the triple? Because we learned the triple. 5, that is correct. So PT is 5. Now, for some reason, kids forget this. What is TQ? What does TQ have to be? Wow. I said TQ. Somebody tell me what PQ is.
Oh, it's just long.
13, right?
It's 8.
So TQ has to be what? 8, because 8 plus 5 is 13. Now that's easy to overlook. That's easy to miss if you don't draw in this radius. All right? That's easy to miss. Go.
How'd you get 5?
Because I knew it was a triple. In geometry, remember we remember the triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those numbers are always used. All right, yeah. Well, because it's perpendicular, do you agree? In the problem, it said that RS is 24. You with me now, right? RS is 24, so bisect, cut it in half. All right, now we can answer those questions. RT is how much? 12. PT is how much? 5. And TQ is? Now, you see how much easier it is if you just go ahead and fill everything in. Then you can answer the question. All right, believe it or not, those are common questions on SATs and ACTs. All right, yes.
I saw there was something about
Okay, so what's PQ? Can you tell me what that is? And again, this is very hidden. I always tell kids when you're taking exams, always, always, always take notice of the radii. The radii are always equal. Do you agree with me now, right? So what is PQ? PQ is a radius, right? It's disguised, right? It's hidden sometimes. The same thing with PS. Notice they didn't draw PS. We had to do that on our own, right? And if you don't draw it on your own, it's very hard to see. That's why I try to tell kids all the time, please draw in a radius, all right? There's some type of right triangle involved all the time. Yeah. Oh, Adam, go. All right, so everybody's comfortable with that, right? All right, so now let's look at 4, 5, and 6. Let's see what they say. The diameter is 12. So right off the bat, if the diameter is 12, I'm just going to come over here and put a 6. All right? Then it says that CD is 8. So if CD is 8, right off the bat, I'm going to put what down? 4 and 4. All right? Now, once again, you can see what I'm talking about. I need to draw what? Yeah, I need to draw AD again. All right? If you draw AD, you can see now the right triangle involved. Right? So what is AD again, guys? Come on. Or AC? 6. Exactly. 6 and 6. All right, now I know everybody can do 36 minus 16, right? Is 20, and then square root of 20 breaks down to what? 2 radical 5. So that means that length right there is 2 radical 5. Everybody good with that? Anybody have any questions? So now if I ask you what this is, somebody tell me what that measure would be right there. Not a decimal either. It's exactly correct. Very nice. 6 minus 2 radical 5. All right, it's a little bit harder to see when you have radicals. All right, go.
Why wouldn't AF and FE be 3 and 3?
AF and FE. Okay, so that's actually a good question. So what I'm going to do is I'm going to come up here and demonstrate why they don't have to be equal. You see the picture, right? This distance, it appears that they are, right? But again, you can't assume that you're always going to be right in the middle. All right, it doesn't have to be. Yes, ma'am.
I'm so confused about how you got 2 that.
I just did. You see, I'm going to draw this right triangle here. And I just did the Pythagorean theorem in my head.
Oh.
The hypotenuse is 6, right? 36. 4 squared is 16. 36 minus 16 is 20. Square root of 20, right? Breaks down to 4 times 5, 2 radical 5. All right? Okay, so I think I answered the questions. Okay, so let's look at, arc CD is 90. All right, which is definitely not true. Does everybody agree with that? It's not really. They're saying arc CD. So let me show you just to make sure. This is arc CD, right? Does everybody agree? It says it's 90. Is that true? Yeah, it's not drawn to scale, obviously. All right, so they want to know what's arc DE going to be. Yeah, 45. Good job. And then what is FD? Yeah, FD was 4. And then what is AF? Yeah, 2 radical 5. Oh yeah, that's kind of easy. What?
For FE, would you have to like do 6 minus 2?
No, that's the answer. You can't combine them.
Okay.
One's irrational, one's rational. All right, another good question. Good for you.
For ED, wouldn't it be like a vertical angle though?
E.
With the 90?
Okay, so are you asked? Yeah, that. Okay, let me make sure. Are you asking me about the arc here, right? This is what you're asking me about.
And like CFA.
CF. Yeah, so this is definitely 90. All right, this is definitely 90. CFA.
Yeah.
Right? So what are you asking me now?
Wouldn't then it be like a vertical angle to EB?
Oh, yeah. Okay, so listen to me now. That's a good question here. So listen to what I'm saying. All right, that's actually very good observation. So what I need to do to show you this is I need to erase this. I need to erase this. So I like exactly what you're saying. So this angle right here is 90. You think that's automatically 90, right?
Yeah.
But now listen to what I'm showing you. This angle, right, and we're going to talk about this in the next coming sections, I believe. So you made a good mistake. So I want to draw something for you. I'm going to make it a little thicker so we can see it. All right, so look. Now, I need you to visualize it. Everybody needs to visualize that. Right? This angle is the same as this angle right here. That's created from that angle. Do you agree? It's not created from this angle right here because those are not the same length. Right? So if I were to swing this open, it would only go to there. You see what I'm saying?
Yes.
This, if I swing it open, would come way out here. So that's not the angle that created that arc. Right? It's this angle here that created that arc. All right, that's actually a very good observation. Not true. All right. The angle comes from the central angle. They call it the central angle because it's formed based off the center of the circle. All right. So that was good. All right, so here we go. Let's finish this off real quick. So circle R, TS is 21. And, okay, so what's true about TS and UW, guys? They are congruent because they're equidistant from the center of the circle. All right. So X has to be what, guys?
7.
Yeah, that was easy. X is 7. All right, and then here, it's telling me that EQ is, they're saying that the arcs or the chords are equal. So if the chords are equal, then their distances are what? From the center of the circle. They're equal, right? So you should go ahead and mark that equal to that. And then that tells you that that is equal to that. Is that correct? GQ is equal, yeah. So help me out, guys. X equals, that's what I got, 5.5. Everybody good? Everybody good? All right, so listen, I really want you to open the book, all right? Your book work, it's really not hard. All right, so let's do that. 664, numbers 1 through 23. All right, page 664, numbers 1 through 23. All right, 664, numbers 1 through 23. Double check your book, make sure it's open. All right, they were having trouble with it yesterday. Everybody good?
No.
Isn't
I'm
it?
so logged out.
Is anyone?
It's your email and Eagles 1, 2, 3. Parker.
I did.
Parker.
He's thank you.
I'll take it.
There we go.
All right, we're back in. All right, everybody's back in.
No cast.